All right, so we're in the middle of the second page right now, the second front-back page, and this is talking about steps for writing a proof. The types of proofs we use are going to be called two-column proofs. Two-column. The reason they're two-column proofs is because we have a list of statements that show what things are congruent to each other and what things are true. And then we have a list of reasons. And the reasons are going to be some sort of postulate, theorem, definitions, properties. But every time you give a statement, you have to give a reason. And the proofs we're going to start off with here at the start are just simply going to be some fill-in-the-blank proofs where you don't have to do them by scratch. We're going to ease into this. So the steps for writing the proof is, first, list the given information. Given information is just basically reading the problem. If you read the problem, it's going to tell you some things that are already congruent. And things that are already congruent, you just write down. Those are going to be usually your first steps. Step 2 is decide if you can use the given information as it is or if you need to make another statement based on given information. A little hint for you, given information is always useful. Math textbook companies just don't give you given information unless it's useful. So you need to make use of the given information somehow. Step 3, list the statements in sequential order. In other words, don't list a conclusion before you list the statement that allows you to make the conclusion. Step 4 is to give a reason for every statement in the proof. You have to give a reason for every statement. As reasons in a proof, you can use given information, label diagrams, postulates, definitions, and theorems. And always end the proof with the statement you are trying to prove. So whatever you're trying to prove is the first step. So the first steps are always given. The last step is always what you're trying to prove. So here's an example of a proof. Example 3. We want to prove that triangle HJK, and that's the bottom triangle, HJK, is congruent to LKJ, and that's the top triangle. So again, we're going to do some fill in the blanks here. HJ is congruent to what? If you look in the picture, you can see that HJ is a double tick side, is congruent to the other double tick side, which is LK. So I'll just put an LK here. Side 2, HK, is a single tick side. It is congruent to the other single tick side, which is LJ. Both of those are given reasons because they were in the picture. They were in the picture, so we say the reason is given. Then side 3. Now we're going to come up with our own side. So what side is also congruent in the triangles? Can you figure it out? Well, hopefully you can see that JK, just kidding, JK is congruent to itself. It's in both triangles. I'm going to triple tick that since I haven't used a triple tick yet. And the reason was actually already given to you because it was the reflexive property. So that should have been a hint. Reflexive property means you're looking for something that's in both triangles. And in this case, it's JK. So the last step is always what you're trying to prove. Remember, the last step is always what you're trying to prove. So you just have to write down this again. HJK is congruent to LKJ. And the reason is one of our new congruence postulates. And since we have 3 sides of the top triangle congruent to 3 sides of the bottom triangle, it's the side-side-side congruence postulate, or SSS. And congratulations, you have just completed your formal proof, your first formal proof. You just got a few hundred more to go this year, and you will be done with geometry. All right, last page. Flip it over. We've got a couple of more proofs. In the diagram at the right, DR is, remember this symbol, perpendicular to AG, and RA is congruent to RG. Write a proof that shows that triangle DRA is congruent to DRG. So the given information is, this is the given information, DR is perpendicular to AG, and RA is congruent to RG. And this is what we're trying to prove. Triangle DRA is congruent to triangle DRG. And a lot of times all this is written out for you already. Now, whenever I have information that's given to me, I like to mark it in the picture. So over here in the picture, I'm going to put DR perpendicular to AG. That means I should put a right angle box where DR and AG intersect. So I'll put a little right angle box there. And it also says RA is congruent to RG. So I'm going to put an RA, I'm going to put a single tick, and then RG, I'm going to put a single tick. And by doing that in the picture, it'll help you remember which parts of the triangles you have already congruent to each other. So right now we have a single pair of sides given to us already. So we go to our two-column proof here. I'm going to have to do some shifting here back and forth because my paper is a little bit small. We have RA congruent to RG. That was given. We've already marked that. And we have DR perpendicular to AG. We've already marked that with the right angle box. Then it says DRG and DRA are right angles. That's the statement. The reason is that perpendicular lines form, well, they form right angles. They form right angles. Now, how do we know that DRA is congruent to DRG? How do we know that these angles are congruent? Well, look at step 3. Statement 3 said that they were right angles. If they're both right angles, then they have to be congruent to each other because we had a postulate that stated that all right angles are congruent. So I'm going to go ahead and mark in my picture the other right angle up here. So now I have two congruent sides and two congruent angles. Now we've got a blank spot. It says blank is congruent to that blank. But look at our reason. Reflexive property. How do we use the reflexive property? Can you remember? The reflexive property is the side that's in both triangles, and that's going to be right here, DR. So DR is congruent to itself by the reflexive property. And then we're down to our last step. Our last step is always, what are you trying to prove? And we're trying to prove that these triangles are congruent. DRA, I mean, you can write the last step, the proof statement, word for word. So DRA, hopefully you can see that, DRA is congruent to the triangle DRG. Now the reason is not the proof postulate. I get a lot of students that just want to write proven here. This is going to be either SAS or SSS for right now. We'll have other reasons later on in the week, but right now it's either going to be SSS or SAS. So which one is it? Well, since it was two sides and an angle, that means it's going to be SAS. Voila, you're done. That brings us to a checkpoint. So, pause the video. I mean it. Pause the video and try to do this on your own. If you can do checkpoint 4 on your own, you've got the first day pretty much mastered. Still got to do your assignment to show me that you can do it, but pause the video and try to do the checkpoint. All right, so checkpoint 4. We have CB congruent to CE as our first statement. Now, where did that come from? Well, that actually came from the given. Right there in the given. CB congruent to CE. CB. Whoops, Mr. Corder, what are you doing? That's supposed to say given. Mental inertia again. So the first statement is given. And then we have reason that 2 is also given, which means we need to write the second part of the given statement, which was AC congruent to DC. AC congruent to DC. Not to be confused with AC DC for you rock bands out there. That's not what we're talking about. It's AC congruent to DC. That's given. And then the third statement, BCA is congruent to ECD. Well, we need to locate those first. BCA, that's this angle right here. And then the other one is ECD. ECD, that's this angle right here. Well, why are those two angles congruent to each other? I'm going to use my fingers to mark off these sides there. And notice that there are two angles formed by the same pair of intersecting lines. They're not adjacent to each other. They are vertical angles. And that's the name of the theorem. It's the vertical angles theorem. Two angles are vertical angles. They are congruent. And that's where you get the pair of congruent angles. So notice what we have so far. We have a pair of sides. We have a pair of sides. We have the angle that's in between them. The angle is in between the two sides. So that means that the triangles have to be congruent. Then notice they've already got the proof statement already written for you. And then what's the reason? Is it SSS or SAS? It is SAS. And there's checkpoint 4. Don't get too overwhelmed by this. If you have had a trouble time remembering definitions, postulates, and theorems from chapters past, the most important ones we're going to be using a lot this unit. You only get better on proofs the more you practice these. If you do not practice these, you do not get better. If you skip the proofs, you never get better at them. So continue to practice, persevere, work till the end of class. Maybe you can get done. Feel free to work with each other. And if you have to go back to this video to check it out, feel free to go back to this video. It's going to be on YouTube till the end of time. So good luck, and I will see you next class period.